Good day, everyone. In this presentation, we will explain the direct method of interpolation using Microsoft Excel and MATLAB. I am Darlene Francia and I will be your presenter. So here are the contents of the presentation. First, what is interpolation? Second, the direct methods in its data points. Third is the example problem. Fourth is problem solving using Microsoft Excel. And fifth, problem solving using MATLAB. So before that, for our number one, we will answer the question, what is interpolation? So most of the time, we are only given an exact and discrete points, such as x is to y, x1 is to y1, and xm plus 1 is to ym plus 1. Therefore, there is a problem when we want to solve a certain value of y at any value of x. This is where we introduce interpolation. It is a continuous function, may be used to represent the n plus 1 data, with f of x passing through the n plus 1 points. Then, one can find the value of y at any other value of x. So it means that interpolation is finding the value between two discrete data or more. So what kind of function should one choose? A polynomial function is a common choice for an interpolating function because it's easier to evaluate, differentiate, and integrate relative to the other choices such as trigonometric and exponential series. So I wrote here linear, polynomial, and cubic because that will be the one that we will study for today. So polynomial interpolation involves finding a polynomial of order n that passes through the n plus 1 points. So a method of interpolation is called the direct method of interpolation, and this will be the one that we will discuss today. So first, what is the direct method and what is its data points? So the direct method of interpolation is based on the following premise. Given n plus 1 data points, fit a polynomial of order n as given below. So this is our working equation, read as y is equals to a0 plus a1x plus so forth and so forth until we reach an plus xn. So this is our working equation. Through the data where a0, a1, and an are n plus 1 real constants. Since n plus 1 values of y are given at n plus 1 values of x, one can write n plus 1 equations. Then, the n plus 1 constants, a0, a1, an, can be found by solving the n plus 1 simultaneous linear equation. To find the value of y at a given value of x, simply substitute the value of x in the equation 1, in our working equation. So, these are the types of data points. So, first is linear interpolation. As you can see here, this is our working equation. And as you can see, we only have 2 points when we use linear interpolation, which is the first order of polynomial interpolation. In this kind of interpolation, again, we will only use 2 points. Next is the quadratic interpolation or the second order polynomial interpolation, where this is our working equation up here. And as you can see in the graph, we are using 3 points. Next is cubic interpolation or the third order polynomial interpolation with the working equation as given above. And as you can see, we are having 4 data points. So after explaining that, it is best for us to solve a problem so we can understand interpolation better. So here is our example problem. So the speed of spread of a bacterial culture is given in the table with 5-minute intervals. Find the area covered by the bacteria in 22 minutes using first, linear interpolation, second, quadratic interpolation, and third, cubic interpolation. As you can see here, here is our data table. For 10 minutes, the area spread in square centimeters is 184.04. For 15 minutes, it's 204.78. For 20 minutes, it's 226.35. For 25 minutes, it's 250.97. For 30 minutes, it's 276.67. And for 35 minutes, it is 304.09. So, Our first part is we will solve this problem using Microsoft Excel. So using Microsoft Excel, we will solve for the example problem. First, we will solve it using linear interpolation. As you can see here, I copied our data table so we can proceed to step 1. So the step 1 is to choose two data points that are closest to t equals 22 that also brackets t equals 22 to evaluate it. The 2 points that I've chose is t is equals to 20 and t is equals to 25. As you can see here, I wrote it in equation form and wrote their functions. The next step is to substitute the value in the working equation and generate the matrix. So this is, as I explained before, is the working equation for linear interpolation. We will just substitute the t that we have and we will equate it to its function because v20 is equals to this. So v20 is equals to, we just substitute the t for 20 and we will equate it to its function. So v25 is the same and we will equate it into its function. We will convert it into matrix by writing the values of t for matrix A. As you can see, A0 is 1, the next A1 is 20, A0 is 1 again, and then A1 is with 25. And another matrix is for our values, the equivalent values, which is 226.35 and 250.97. Let's call this first matrix, matrix A, and this second matrix, matrix B. So the value of A0 and A1 is what we will solve for today. As you can see here, I just copied our matrix and our matrix A and our matrix B. So the first step to find the value of A0 and A1 is clicking the same amount of cell where your matrix is. As you can see, I have here 2 by 2 square, my 2 by 2 matrix. So I will cover 2 by 2 as well. Then, in the formula bar, just write equals M inverse. It will pop up. Click it and highlight your array. The array is the matrix that we will inverse. So we will inverse the matrix A. After highlighting, just close it with the parenthesis and hold Control, hold Shift, and press Enter. Now, we have the inverse of our matrix. Don't forget to hold Shift and hold Control. The next thing we will do is we will multiply the matrix B with our inverse matrix so we can have the value of A0 and A1. So how will we do it is, again, we will highlight the amount of columns of our matrix. As you can see, we can multiply matrix B to matrix A because they have the same amount of columns. So we will highlight only 2 columns because our matrix, in the inverse matrix A and the matrix B, both have 2 columns. Highlighting 2 columns and putting in the formula bar equals M U L T. It means matrix multiply. So click it and now we will choose our first array, our first matrix, which is the inverse matrix A. Just copy it, press comma, and then copy our second matrix. Close it with the parenthesis, hold Shift, hold Control, and press Enter. Now we have the value for our A1, A0 and A1, which is 127.87 and 4.924 respectively. So after getting the value of A0 and A1, we will now just need to substitute it in our working equation. But don't forget to put the range of your answer. So our range is our lowest value, t in the middle, and the highest value. So the lowest value of t that we use is 20, and we're finding something in the middle. The value of t in the middle and the highest value that we use is 25. So at t equals 22, we can now substitute and solve for the problem. So A0 is 127.87 plus A1, which is 4.924 multiplied by 22, we will get the answer of 236.198 cubic centimeter. So the next way of solving our sample problem is using quadratic interpolation. The only thing different with this is that we are using 3 points instead of 2. So the same first step, we will choose our data points, but now we will choose 3 data points. That still brackets T22. Remember, it still needs to cover T22. So I chose 15 minutes, 20 minutes, and 25 minutes. As you can see here, I chose it and wrote its equivalent functions. So again, same step 2, we just need to substitute the value of t for each function and equate it to its value. So for v15, we just substitute the t with 15 and put its value. Same with t20 and t25. And as you can see here, we will just create the same way of creating matrix. So first is A1 is 1, A0 is 1, A1 is 15, and A2 is 15 squared, which is 225. So again, the same one here, A0 is 1, A1 is 20, and A2 is 20 squared. The same with V25. And this will be our matrix A again, and the matrix B will be the equivalent value of each function. So, as you can see here, I already copied our matrix. So, this is our matrix A, which is 3 by 3, and our matrix B, which has 3 columns. Okay? So, again, we will do the same. We will highlight the same amount of cell that we have on matrix A to inverse it. So, we have 9 cells. We are highlighting 9 cells because this is a 3 by 3 matrix. So again, press equals M inverse, and we will choose our array, our matrix, close it with the parenthesis, hold control, hold shift, and press enter. Now we have the inverse of our matrix A. The next thing we're going to do is to multiply matrix B with matrix A. So we will count the number of rows it has, and we will highlight it. So after highlight, since we have 3, we will highlight 3 cells and press equals MULT, which is matrix multiply. So we will choose our first matrix, which is the inverse matrix, and press comma, choose our second matrix, and close it with a parenthesis. Hold control, hold shift, and press enter. Now we have value for our A0, A1, and A2. So as you can see here, I just substitute the value of A0, A1, and A2 to our working equation. And don't forget again about the range, since we used a lower value for this quadratic one than 20. So the lowest value I have is for t is 15, the t in the middle, and the highest value is t25. So at t22, I just substituted the values and computed 235.832 square centimeter. So next one is the cubic one. So it's the same, but again, we will, as I explained, we will choose 4 data points. For me, I chose 15, 20, 25, and 30. As you can see, I wrote the t that I chose, and it's v to t. As you can see. Then, for step 2, I just, again, substituted the value of t and its corresponding function value. As you can see here, for v is to 15, and v20, v25, v30. So, here is how I made the matrix. Again, for v15, just put 1, A1 is 15, A2 is 15 squared, which is 225, and A cube is 15 cubed. So on and so forth, as you can see. And that will create a 4 by 4 matrix. And for its corresponding value, we can see a 4 by 1 matrix. Now we will compute for 3 A values. A0, A1, A2, A3. I mean 4 A values. Sorry. So as you can see here, again, I just copied our matrix. Exactly. So it is a 4 by 4 matrix. And we will need the same area to highlight for the inverse matrix. Again, this is 16 cells because this is 4 by 4. We will just highlight a 4 by 4 box here. Go to the formula bar, press M inverse, parenthesis, then select our matrix A, close it with a parenthesis, hold Control, hold Shift, and press Enter. Now we have our inverse matrix. And the next step, as usual, is we will just multiply our matrix B to the matrix A. Matrix B have 4 rows, so we will highlight 4 rows. Then we will go to the formula bar and put MMULT, or matrix multiply, parenthesis, choose our first matrix, which is the inverse matrix A, then comma, our next matrix is the matrix B, close it with the parenthesis, hold Control, hold Shift, and press Enter. Now we have our values for our A0, which is 178.07, our A1, which is negative 0.907, our A2, which is 0.2186, and our A3, which is 0.0026. So we will just, again, substitute the value of the A's, and we will insert it in our working equation. Again, we will do our range. The lowest that we use is 15, the highest is 30. Here, at t is equals to 22, we'll substitute the A0, A1, A2, and A3, and put the values of t, which is 22. We will solve it, and we will get 236.227. So for the next part, we will solve the exact same problem using MATLAB. So we can see that there is no difference, and we can actually see which method you prefer using. May it be Excel or MATLAB. So for this part, we will solve the exact same problem but by using MATLAB. Again, this will yield the same answers, but I will just explain you the different methods on how we can solve for direct interpolation. So first, I will teach you how to make a matrix in MATLAB. So it is simple. The first thing you need to do is to put a name variable on your matrix. As we've been using before, as you refer to the Excel part, we use A for our first matrix. So A is equals to, we use brackets, and then we will type the numbers horizontally or by row. So the first row that we have is 1 and 20. So 1 space 20, and then we will put a semicolon, and this will tell the program that the line breaks there. So it will start another line. So we will put our next line, which is 1 space 25. The space is what signifies the first number and the second number. We will just close the bracket and we will press enter. So we have our first matrix. Again, we will solve this using linear, and I will show you the quadratic and the cubic as well. So this is our first linear matrix. The next one is the B matrix that we have, which is the equivalent function value. So we will put B, then equals, then again bracket. Then our values there is 226.35. Please refer to the Excel part where we have a visual representation of our matrix. Then again, this is the only one in the matrix line, so we will break it. And we put the another value, which is 250.97. Make sure that the values are correct. So we will press enter. So now we have our two matrices. Unlike in Excel that we need to inverse A, in here we can just put it in our formula. So we will signify the values of A1 and A0 and A1 using X. So X, it is equals to the inverse A. As you can remember, we inverse A. So inverse, INV, parenthesis, our matrix A. And then we will multiply it by using asterisk. And then we will press B. The program will recognize this since we already established that A is equals to the matrix 120, 125, and B is equivalent to the other matrix. So after pressing enter, it will give us the same answer as before. As you can see, and you can double check it, it is 127.87 and 4.9240. So for the other parts, I will not repeat on how doing a matrix, it's just the same. So I will just clear our board. And I have here already our matrices. So this is for our quadratic matrix. As you can see, it's just the same. I just put it 1, 15, 2, 2, 5, semicolon, 1, 20, 400, semicolon, 1, 25, 6, 2, 5. It is that simple. Next, we will put our B matrix again, and we will again multiply inverse A times B, and we will yield the same answer. It is the same as I did with the linear. So we'll clear it. And for the cubic part, here, you need to type everything manually. This is just in my command history because I already solved for this. So again, just write the A matrix like this, horizontally per row. So 1, 15, 2, 2, 5, 3, 3, 7, 5. As you can see, that is that part, this part, so on and so forth. So we will do our B matrix as well, just like the linear, but just add a little more value. So you can see here. And again, just do X, which is our value for A1 and A2, A0, A1, A2, A3, and equal inverse A multiplied by B. So this is our A0, A1, A2, and A3 respectively, as you can see. So you can see that MATLAB is much easier, especially when you know how to command the program properly, and it is a little bit more precise. I mean, you can adjust the calibration of precision in Excel, but in my preference, I prefer using MATLAB because it is a easier way to solve for direct interpolation. Plus, it can also store your commands and your matrices. Again, after finding our A values, we will just do the same procedures. We will just substitute the values and substitute T for 22 and solve. It is easy to do this, but if you know how to use programs properly like Excel and MATLAB. So that will be the end of my presentation. Again, my name is Darlene D. Francia, and this is a special project requirement for Reggie Duenas. So thank you for listening, and I hope you learned something from my presentation. I hope this finds you well, and have a nice day.